Hey guys, I'm Caitlin.
And I'm Drew.
We're from 4545 Ouroboros, and this is our general hardware presentation. This is Oro, the fish, and he's going to be helping us with the presentation today. Our table of contents today includes intro to hardware FTC, design processes, building systems, electronics, motor servos, FTC restriction, types of wheels, drivetrains, gear ratios, and lifts.
So, what is hardware? Hardware is the aspect of where you essentially design and build the. And there are four aspects to it. There's obviously designing, prototyping, CADing, and then finally building. And our goal is to help you design and build a robot that can complete the challenges given to you by FTC.
All right, so the design processes we use in FTC are first to analyze the game. So, what is the game? What's the constraints? To be able to develop a scoring strategy. So, how do we get the most points out of the game? Third is to brainstorm mechanism ideas, then prototyping it, drawing it out on CAD, and finally building.
So there are a bunch of different build systems. There's Robotics is one of the two main build systems in FTC. You have GoBuilda, you have and Mars Aerobotics, Andy Mark, and Vex. And then there's also custom where you make your own parts.
So, a big type of building system we use in FTC is Rev Robotics. We use Rev for our structures, motors, servos, and electronics.
And an alternative to Rev is GoBuilda, which has that Rev does.
All right, and for support, we use Actobotics, Animark, and Vex. We use them for wheels, screws, standoffs, and hardware basics like bearings, washers, collars, and chain and sprockets.
And then finally, there is custom, where you essentially fabricate the parts specific to your robot, and it's unique and it's different than the rest of the systems.
So hardware on 45 looks like a lot of 3D printing, CAD, CAM, and general mechanism that we just talked about.
So we use a lot of electronics in FTC. So one of the main ones are the Rev engine hubs, like the Rev battery, the any FTC legal camera, a level shifter, which is when you use it to shift between different voltage, various sensors like the color sensor, distance sensor, and finally the servo power module.
All right, and so motors and servos, what are the difference? So, a motor is a machine, especially one powered by electricity or internal combustion, that supplies motive power to for a vehicle or for other devices with moving parts. Servos are very similar. However, servos are a smaller version of a motor, and we use servos from Rev, GoBuilda, and Vex.
So there are a bunch of different motor ratios, but the main golden ratio, which is 20 to 1. And the reason why this is the golden ratio because it's the perfect balance between speed and torque, and it's mainly used for drivetrains. And if you need more power torque, you want to increase the ratio from 40 to 1. And we use this specifically in like intakes if you need more power and stuff like that. And if you need more speed, you want to decrease the ratio 13.7 to 1, 0.2 to 1, 3.7 to 1. And these are ratios for gold build.
Yeah, and going back to motors versus servos, motors are larger and heavier. They have more power and allow sprockets and gear to be easily attached. They're used especially in drivetrains, lifts, and intake. For servos, however, they are lighter, smaller, more compact, and they have detachable plates for mounting. and they're used more to manipulate things.
And then here are the FTC restrictions for like motors, servos. So you need 8 motors is the max you need for FTC. 12 servos is the max. 2 rev expansion hubs or 1 control hub, 1 expansion. 2 phones if you don't have a control hub. 1 power servo module and 1 battery.
All right, and these are the type of wheels we use in FTC. Coming from upper left to the lower right, we have compliant wheels, Magnum wheels, Omni wheels, a smaller version of an Omni wheels, stealth wheel, smaller stealth wheel, monster wheels, and tank threads.
So what is a drivetrain? A drivetrain is normally located at the bottom of the robot, and it contains the mechanisms that allow us to move in the field. So there are 4 main types. There is tank drive, there is stealth, swerve, and holonomic.
All right, so tank. Tank is built with 4 to 8 stealth wheels. The great thing about them is that they're fast and they give us great grip when we're driving. However, the cons with them is that they are not great at maneuvering.
The second one is stealth. This drivetrain does have like many wheels, and they're fast with grip, and it adds maneuverability that tank drive does not. But if you want to strafe with them, it's pretty limited.
So with swerve or holonomic, they are composed of 3 to 4 swerve wheels, like chair wheels. The pros with them is speed and maneuverability. However, they're not great with traction and terrain is a big no, it's not great.
The last one is holonomic, and these ones are focused more on maneuver. Mechanism wheels are a perfect example. You can strafe and turn easily with precision in different directions, and we actually use Mechanism drivetrain in our robot this year.
All right, so for honorable mentions, the one on the left, very far left, is called West Coast, and the other 2 on the right are H drives.
So we're going to go a little bit more into gear ratios, and if a larger gear is being powered by a smaller gear, it will turn, but it will have more torque, meaning more power. If a small gear is being powered by a larger gear, it will turn, but with much less torque. And this is represented with input and output. So if the input is 20 and the output is 40, then the ratio is 2 to 1. So the output spins half. But if the input was 40 and the output 20, then it would spin at twice the speed.
So these are some of the lifts that we use in FTC. The ones on the left are shown are linear lifts. They can either be vertical or horizontal. And the one on the right is called a scissor lift, and they're parallel.
All right, thank you guys for listening. And if you please don't hesitate to email us at 4545.ouroboros@gmail.com. Thank you.